Welcome to this live webinar with Nexenta and IDC. My name is Wahlberg, and I run product management at Nexenta. And today I have Ashish Nadkarni from IDC with me. Together we're going to talk about storage challenges that we face today, from new applications, from new workloads, and why traditional storage solutions have been challenged by them, but also how a new generation of storage solutions and scaled-out technologies help solve these problems. So with that short introduction, I'm going to hand it over to Ashish Nadkarni to talk about some of his insights that he's gotten through IDC and some of the challenges that we face today.
Thanks, Oscar, and hi, everybody. Welcome to the webinar. I'm part of IDC storage team, and I cover emerging technologies like software-defined storage, file and object storage, big data, and business analytics. And I'm glad to be here to talk about why there is a need for massively scalable software-defined storage for the IDC third platform era, and we'll jump right into the reasons for it. The IT industry is in the midst of a massive transformation, and the transformation is what I would call as almost like a paradigm shift, going from what used to be the first platform era, which used to mostly comprise of mainframes, and then we saw the second platform era, which is really about open systems, client-server models, and such. And then we have what we call as the third platform era, which is going from hundreds and thousands of apps to millions of apps, from hundreds and thousands of users to billions of users. And when you factor in things like Internet of Things, social, mobile, cloud, you're talking about trillions of things or trillions of objects. The four pillars on which the IDC third platform era really rests on is mobility, cloud, social, and big data and analytics. Together, these four pillars are governing most of what businesses are doing today. They want to be able to have an agile infrastructure, almost like a cloud-like infrastructure. They want to be able to analyze everything they do. They want to be able to, conduct their business in a socially friendly manner. And of course, they want to be able to have a mobile-first strategy, which means that they need to essentially have all their applications delivered via a mobile interface. What that means then is all of these newer innovation accelerators, as we call them, robotics, natural interfaces, 3D printing, Internet of Things, cognitive systems, next-gen security are all kind of derivatives of these four essential pillars. And eventually what that means is it is going to bring about a massive transformation in how businesses go about doing their business. So there's a need for immediacy. People want their results right then. They cannot wait for it. It changes how work is conducted in the future. It changes the abundance of data. It changes how things are bought. There's new buying centers. People are demanding efficiency. They're demanding personalization. And when you take it all together, sort of soak it in, it comes down to that there is a continuous industry transformation, and on that industry transformation is all of these things that kind of change IT functions. And if you look at the growth that we're projecting for all of these newer applications, it's 15% or higher, and that's conservative. But if you look at all the older platforms, that's around 0.7%, and so you can see that where their massive investment is going towards is towards some of the newer innovation accelerators, these third platform technologies. And to give you some stats on, how this is changing, you can go through these. I'm not going to read them all, but you can realize how massive this transformation is. We are not talking about peanuts here. We're talking about really massive, big-scale transformation. And what it comes down to is that your IT infrastructure needs to be prepared to run this transformation. If you don't change the way in which you think, then change will overcome you, and IT will not be able to support the businesses that, or the transformation that their respective tenants are going through. So trying to go to the next slide. Okay, so it's a little slow. My apologies. All right, so what, I think I went one slide too fast. So what that means in the data center is that the infrastructure problem is kind of defined by how your tenants are changing, right? So you have more devices to work with, you have more content to work with, you need to be able to analyze all that content, you have more means of kind of changing how you manage the compute stack. So there's virtualization, there's containerization, there's more applications, and ultimately you're dealing with more data growth. So when you take that all into account, you are essentially saying that the infrastructure problem is changing your priorities for third platform. And then when you go to the type of data that is changing, you're going from a unstructured kind of, you're going from a structured kind of a data that is very rigid, what that data type is going to be, and you can sort of format your schema ahead of time, to sort of an unstructured data environment where the data types are unknown. You cannot kind of manage the schema, so you have to rely on newer types of storage platforms. So traditional storage is sort of falling short of the data requirements for third platform era. And as you can see, if you take scalability into account, you take data integrity into account, you can take security into account, and of course cost efficiency into account, you cannot have traditional storage systems that scale to that level. And when you have to look at why is that the case, one of the reasons for that is the data files of your applications are evolving. There used to be applications that were centralized in a single data center, and everything was sort of in this one single data center. But nowadays, you have applications that are decentralized. You have applications that require workload adjacency, so you cannot have workloads run separately from the data. You cannot move the data to the compute. It's just inefficient. So you need to have workloads run in a location-aware manner. You have geo-dispersed data sets, so you have data sets that are distributed, portions of those data sets going on. So you have distributed data sets that are, portions of the data sets can be in different locations. And of course, now you factor in things like social and mobile usage, and machines generating more semi-structured data. You have operational data, you have Internet of Things data. You need to have a different kind of storage infrastructure. You cannot have the same centralized approach to storage. You need to have a decentralized approach to storage. So how does infrastructure get defined? It has to be agile, it has to be software defined, and I'll come to software defined in a minute here, but it needs to be able to deliver public cloud economics for your private cloud. And why do you need it? You need it because it needs to scale on demand, it needs to be highly agile, it needs to allow you to control costs very easily. You need to now be operating in a CapEx-friendly manner, which means more of your spend needs to be in an OpEx-heavy manner. And ultimately, it needs to be a service-based infrastructure. And what you're getting is the more value it can provide, the quicker it can respond to the demands of your business units. And the solution is a software-defined infrastructure. It's a solution that can provide you all of these attributes. And then, of course, you get the ability to kind of take the storage infrastructure and apply them for new next-gen applications. So what is that? So if you look at applications storage profiles in the form of sort of this pyramid, then at the very top, you have these all-flash, high I/O-intensive storage arrays, followed by performance optimized. So in the case of the flash, you have, absolutely no wriggle room for any kind of latency, right? And then you have performance optimized, where you need to handle unpredictable spikes. You know that the spikes are going to be there, but you just don't know when they're going to be there. You take one level below, go one level below, you have these capacity optimized apps, which usually most mainstream apps kind of fall into that bucket. And then finally, you have cold storage or longer term storage, which is basically the lowest cost storage. And if you kind of build the cost performance vectors on them, you realize that as you go down the pyramid, your performance requirements go down, and as you go up the pyramid, your cost requirements go up. So the key here is to find a balance between how you are going to tier your storage, but you have different purpose-built infrastructures for each of these buckets or profiles that dictate what kind of application it is. And you can see there that 60 to 90% of all the data lives in the capacity and longer term storage, whereas really small amount of data sits in the the top tier, if you will. And here's all the different application profiles that are really looking at next-gen applications for third platforms. So you have application acceleration, you have analytics, you have productivity apps and databases, which are not going away anywhere, but you have newer types of databases, NoSQL databases. You have archiving for all this massive data that has been generated, and so on and so forth. All right, so what are some of the 4 technologies that we think are disrupting enterprise storage? First one is Flash. Flash is really critical to the for your ability to provide predictable performance. No longer do you need to have lots and lots of storage in order to provide that predictable performance. You can basically provide it using a small amount of Flash, and you can gain a lot of economics in terms of how much you're consuming. The next is convergence, the ability to package compute, storage, and networking together, whether it is packaged in a native fashion, hyperconvergence as an example, or whether you're packaging it in sort of a build in the channel or build at the customer site kind of model. Third one is software defined, and I promised I'd talk about software defined in a minute. Software defined is really about the ability to take or decouple the software stack from the hardware stack and provide a very flexible way of managing your dollar per gig using a combination of internal and direct attached storage. There's plenty of options there, and software defined is certainly not a one size fits all. There's different types of software defined storage systems, such as the one that Nexenta is going to talk about today. And clearly this provides a big opportunity for building the fourth one, which is cloud. You need to have architectures that support a very on-demand kind of a service-based model, and is a massive transformation of how you deliver resources to your applications or how you build applications. Together, software-defined and cloud are really going to govern how infrastructure gets built in the next third platform era, which is already upon us. So a lot of you are listening to this webinar today because you have had at some point an interest or an interaction on the ability to kind of convert your infrastructure into a private cloud-like infrastructure or a private cloud infrastructure and use software-defined storage, software-defined compute, or software-defined networking as underpinnings for that cloud infrastructure. So most massively scalable object storage systems, IDC considers them to be a form of software-defined storage. So in IDC's terminology, there is really 4 sort of building blocks of software-defined storage. First of them is data organization. And what that means is you have different types of data organization. There's file-based, block-based, object-based. If you follow a flat container-like organization, then that's one type of organization, and that is what most object storage systems or object storage platforms leverage. The persistent data stores can be in form of internal drives, it could be in the form of cloud, it can be in the form of a direct attached storage, but most of these are shared nothing architectures, which means they are built using commodity building blocks. They leverage a local file system, or in many cases, a way to access a block device at a lower level. And then from a storage services perspective, they offer object storage interfaces such as S3 or OpenStack. And for data resiliency or data availability, they employ replicas or erasure coding. And more importantly, one thing that differentiates object storage systems from everybody else is the ability to have rich metadata, and in many cases programmatic metadata that can also be dispersed, along with the data itself. So you are no longer talking about a system that is confined to a single data center. You're talking about a system that can now span multiple locations, multiple data centers, including the cloud. And that is really where the world is going. That is really where storage infrastructure is going. You are no longer limited by a single location. And if you want to see it in action on your consumer side or even on the enterprise endpoint side, you need not look any further to look at your favorite file sync and share application. Most file sync and share applications today are built on geodispersed capabilities. So you have the ability to kind of be anywhere and still have your files be synced to this file sync and share solution. Most of those file sync and share solutions, leverage an object storage as the infrastructure component. And from a delivery model perspective, software only, physical appliances, cloud, virtual appliances, it's really about offering flexibility. It's really about offering the buyer the convenience of acquiring these systems or platforms in a way that makes it easier for them to deploy. And I just talked about all of these features. One thing to note about object storage systems is that they leverage this flat namespace, which is often talked about in the context of a tenant, account, container, and object. So instead of using a hierarchical namespace, which is sort of what all these file systems employ, or even NAS platforms employ, object storage systems definitely are not that. They offer a flat namespace, and the flat namespace lends itself well to a lot of data types where your object may have a rich set of metadata tags associated with it or metadata attributes associated with it. So I'm just sort of building this out. All right, so what are some of the attributes of leaders in the object storage market? The first thing is unconditional commitment, and I need not say more about this. Object storage does tend to be something that a lot of buyers don't easily grasp, but have to work hand in hand with product development, business and financial marketing, all these different teams to kind of provide that value proposition. Partnerships are important as well. And the only way object storage system vendors can do that is to have this unconditional support, because it is really a new and emerging technology, and you cannot take your eye off the ball. It needs to be really focused in making sure that this technology is pervasive and is definitely there to stay in the enterprise. And in fact, it is already successful in the cloud, so it's time for the enterprises to embrace it. Product capabilities are important. Product strategy is important. Versatility is at the top of the list because of the sort of the competitive landscape. Revenue is certainly going to follow once product management has done their job. And global presence matters because you need to be able to deliver this product to a worldwide audience. In fact, a lot of your audiences of vendor audiences are going to be in a lot of these emerging countries or developing countries where people are deploying newer solutions, mobile solutions that require a massive storage platform. So what are some of the product capabilities? The first is data reliability, availability, and durability. Keep in mind that these are massively scalable storage platforms, so you don't have the luxury of backing up a petabyte-scale storage platform. You cannot do tape backups on these object storage platforms. They have to be fully built in the form of having their own reliability mechanisms, durability mechanisms, availability mechanisms, and at the same time offer a full set of service level attributes, service level objectives. The second is that it needs to offer a seamless, no forklift model. You cannot kind of take a 10 petabyte or even higher object storage system and have a forklift upgrade because it's going to take you more time to move it than this refresh cycle itself. So you should be able to add capacity or replace old hardware in sort of a rolling fashion without interrupting the system or even stopping the system. The third is data security. Keep in mind that a lot of these object storage systems are deployed in systems where, or deployed in environments where the applications have are going to store a lot of sensitive information. So should be able to work with regulatory audit compliance mechanisms. Encryption is not certainly an optional thing in many environments. So industries like healthcare and federal government and even in financial services, data security is a mandatory requirement. The next is performance. We're not talking about only capacity optimized long-term storage here. We want object storage systems to be flexible. They need to have the ability to tier data. They need to be able to leverage flash. And then, of course, cost efficiency, which is really, if you're using commodity hardware and you're using things like replicas versus erasure coding, how do you manage cost efficiency? And then finally, you need to be able to have support for multiple workloads, multiple use cases across multiple verticals. So it's really about versatility and flexibility at that point. These are some of the workloads and use cases. So for example, active archive, item preservation archive, business analytics, in-place business analytics, content depots, hybrid cloud, general collaboration, file sync and share. I mentioned that as a use case. Cold storage, being able to store all the data sets that are no longer needed. It could be X-rays of patients, or it could be old financial records. And then, of course, dispersed machine-generated data. You're going to have tons and tons of machine-generated data when Internet of Things rolls around. How do you deal with it? You need these geo-dispersed storage systems. From a partner ecosystem perspective, you need to be able to have a commitment to building comprehensive ecosystem, because let's face it, you cannot be, even a large company like GE and or even IBM for that matter have a hard time kind of doing it all on their own. You need to have a partner ecosystem that relies on best-of-breed partners to provide you that extension of your storage system. So, for example, if you're going into the healthcare vertical, then you need companies that specialize in the healthcare industry. And so the same thing applies to the storage here. You need to be able to have, and I'm saying you is in vendors that are in this market need to be able to have that ecosystem built out so that they can make sure their object storage system is qualified for all these newer applications and use cases. So what are some of the, or what is some of the essential guidance that we could offer, IDC can offer to buyers who are, offering or examining this new product or vendor? First is looking at the application or workload. What is the application or workload that is going to dictate what kind of platform you're going to need? Sometimes you might need a tightly consistent platform that is really only designed for a single data center, but in many other cases you might require an eventually consistent platform that can function in multiple data centers. Same thing from an architectural feature function. You might have situations where you need this to function only with Amazon S3, or in some situations you might need it to have a rich policy management thing for data tiering. You might have a situation where you want programmatic metadata access. So those are really the two main ones that I would offer right now. The rest are really vendor level things that are more specific to the vendor's situation, whether it's geographic location, what reseller you're working with, etc. So what are some of the key questions you would ask? First is you should ask about platform scalability. How massively scalable is this platform? And from a hardware perspective, from a throughput bandwidth perspective, file size, file volume, how scalable is it? So you almost need a checklist of all the features and find out how scalable they are. The second is deployment flexibility. Does the supplier offer deployment flexibility in terms of how this platform is deployed? Is it software only? Is it available as an appliance? Can I get a cloud edition? Can I get it as a virtual machine? Data management, how advanced are its data management capabilities? Storage efficient, how does it treat data optimization? Does it offer compression? Does it offer deduplication? These are important because you need to have the ability to deduplicate data. You're not going to store the same amount of data many times, and just waste your storage. Data resiliency, like I mentioned, you need to have built-in protection from hardware failures. So replication and erasure coding offer those kind of resiliency capabilities. And then workload adjacency. How do you manage distributed and localized workloads for things like business analytics, Hadoop, hypervisors, etc. And then finally, how can you ingest and store the data? How does it handle large files? How does it handle small files? What are the sharding capabilities of the system? And from an organization perspective, and I'm just going to quickly build this slide in the interest of time, really it is about an opportunity here. It's an opportunity to become more agile, deploy a storage system that takes a very radically different approach to how storage is getting deployed for the future, and to kind of allow you to become more collaborative with our business units while reducing costs. And from a resource perspective, this is really about adopting new resources, changing your buying patterns, shifting some of your CapEx dollars to OpEx, and really about making sure that your storage infrastructure is consolidated and optimized for next generation IT. And it is about higher return on investment on a reduced total cost of ownership. And with that, I'd like to hand it over to Oscar. Thank you again for your time. I'll be around for questions and answers.
Thank you very much, Ashish. There's some really interesting insights, and it actually ties very well into what we have seen at Nexenta. And for those of you that are not familiar with Nexenta, I wanted to give a brief overview of what we are and what the company is. We're really one of the first software-defined storage companies. We're founded and we released our first product in 2008. Today we have about 6,000 enterprise and community edition customers with more than 1 exabyte of storage provision. So quite a broad customer base with a lot of storage, and that really taught us a lot about how software-defined storage works in the enterprise. As I mentioned, we're a software company. We sell software-defined storage solutions through a rich partner ecosystem, and that's really the enabling factor for us. We work with any industry standard hardware, so x86 hardware, direct attached disks, JBOD, and so forth. On those, we run Nexenta software, so Nexenta Store, providing unified block and file services, or NexentaEdge, our scale-out object and block storage platform that we're going to talk a bit more about later on. But really, the combination of those storage layers allow us to present storage through a variety of protocols, be it file, block, or object storage, out to any platform. And with any platforms, I really mean any object consuming application, any operating system, Linux, Windows, or any hypervisors such as Hyper-V or VMware. We really work in all of these environments, as well as integrate well into a number of different ecosystems such as OpenStack. The way we do this is really through our software stack and software-defined storage. And for me, really what that is and what defines software-defined storage is really flexibility and choice. It's really about allowing you to design your solution using your preferred hardware vendors, or using predefined reference architectures to give you a bit of headway. But it's also about being able to take that initial deployment, and as your workload changes, you can change the hardware infrastructure you can build on that to deliver something more. So it's easy to integrate into existing infrastructures. It's easy to start small and grow on demand. Those are really some of the key differentiators for me when it comes to the software-defined storage market. And it's something that we've done for a long time. And we started seeing some of the challenges that Ashish mentioned in his presentation probably around 3-4 years ago, when we were starting to see emerging new applications. And at that time, it was largely around private clouds, virtualization, and so forth. But going on beyond that, it was Hadoop, data analytics, and now the containerization movement with Docker and Kubernetes and so forth. Really, what these applications and workloads are doing is that they're creating unique storage challenges. All of a sudden, the scalability demands go into multi-petabyte deployments. The ability to elastically add storage capacity or shrink storage capacity to individual applications and move those resources around dynamically as your environment requires it and as your workloads requires it. All while maintaining predictable costs, not only from a hardware perspective, but also from an operational model. Those challenges aren't really met by traditional storage. And Ashish mentioned that traditional storage is starting to fall short. And I think this is really a key segue into the software-defined storage market. Because what we saw when we looked at this and these emerging workloads about 3.5 years ago, we started seeing that we think we can do more with the technology that's available today and the technology that's available in our hardware vendors' roadmaps. We were looking at things as the Intel Xeon chipsets, and they were building in a lot of rich instruction sets that enabled you to do strong cryptographic functions internally within the Xeon processors, for example, to offload the software from doing that, accelerating the performance of what we can do with the software. We're also seeing large capacity hard drives coming to market, and now we're up to 8 and coming to 10 terabyte drives, as well as the advent of flash, if you want to call it that. Really, the flash storage started coming out and being commoditized within the enterprise, and now we're at the point where, at the top of the pillar of high performance, you have these all-flash arrays that have really sub-millisecond latencies ideally. All of these technologies, when you bake them in together with intelligent software, really allow you to design and implement new solutions to address these new generation workloads. And that's what we started doing 3 years ago. We started developing what we call NexentaEdge. And we released this product at the OpenStack Summit in Vancouver earlier this year. And what it is really a scale-out object and block storage cluster. So we take industry standard x86 hardware with direct attached storage and connect those to a back-end storage fabric using 10 gigabyte Ethernet or above. And really, many of these nodes form a cluster that share a single flat namespace, either through block interfaces, through iSCSI, or as object interfaces using OpenStack Swift or Amazon S3 storage services. So the whole system is designed to scale from hundreds of terabytes to many, many petabytes. And we're talking about potentially tens to 100 petabytes with thousands of devices and servers. Really focused on optimizing not only the storage platform, but also the networking platform that we rely on. So we focused on delivering a couple of key things: the sense of end-to-end data integrity, advanced enterprise storage functionality in a really easy-to-use package. Those were our kind of 3 key tenets that we wanted to touch. And we did that with a mindset that we want to be able to address multiple workloads and multiple application use cases. And we're seeing this being very successful in a couple of types of environments. So the private cloud environments with OpenStack clouds or VMware environments, so kind of scale-out storage for VMware, where our technology around providing iSCSI block services, either through OpenStack and Cinder, or actually object storage as well into OpenStack. Our technologies around inline data reduction through compression and deduplication allow us to create a very cost-efficient and high-performance storage layer for these environments. Another key use case and deployment scenario that we see is something that I call active archives, which is really a combination of different things. See it as large content repositories for rich media, application backups, anything where you need to scale your storage to many, many petabytes. And you're accessing this through object interfaces predominantly, Swift and S3 today. Again, this is something where NexentaEdge really shines, both through the inline data reduction capabilities, but also how we manage storage over time to make sure that we avoid creating hotspots and really make it easy to grow the environment. And that use case really dovetails nicely into the big data analytics, where we can provide back-end storage for things like Hadoop in the HDFS space by integrating into the Hadoop file system as well. So when we looked at these challenges and the challenges that these use cases really provide in a scale-out environment, we hit a couple of things that we really a couple of problems that we really kind of wanted to solve. The first one was really that when you scale a single storage system up to many petabytes of storage, fundamentally, it's not just so much about tracking the data as tracking the metadata of these, the stored objects. So when you store billions and billions and even trillions of objects into a single storage system, all of those objects needs to be tracked. The metadata needs to be tracked and stored. And having a centralized metadata repository or server just doesn't scale very well. It doesn't scale to the limits where we wanted to go. So one of our core tenets was that we wanted to have a completely decentralized metadata service. So in our NexentaEdge system, all the metadata or the object metadata is actually stored just as another object inside the object store. So obviously we maintain data integrity, we maintain resilience across that metadata, but the key tenet here is really that we've distributed across many storage nodes in a completely distributed fashion, allowing us to scale this to as high as we need to. So that enabling technology is something that I would call distributed copy on write, or as we call it, cloud copy on write. That was one of the enabling technologies that we have within the NexentaEdge. We have two other technologies that really enable us to hit these use cases. They're called FlexHash and Replicast. FlexHash is our dynamic data placement and algorithm, and we use that for hashing, we use it for data placement, and really what it's about is addressing the ability to dynamically place data in a consistent manner across a large number of devices within your cluster, and yet place it on the devices that have the lowest latency or best performance. So we utilize a strong cryptographic hash, actually it's a SHA-256 or higher, as the basis for this algorithm. We then have what we call a negotiation phase across our Replicast protocol. Our Replicast protocol is really the way we communicate between our storage nodes and our gateways. It's our communication protocol. What this negotiation phase allows us to do is pick the best disks and best devices within your storage infrastructure that will perform the best for this particular write or read. So this allows us to return to the applications faster. It allows us to prioritize disks with low latency, so we can automatically benefit from using SSDs, for example. So what happens is that we take this strong cryptographic hash, we have a negotiation phase across Replicast, and we pick the best devices to store this data on. We do that based on latency, as I mentioned, and utilization, and this really allows us to provide low latency small random I/O performance. It also allows us to balance our load across many nodes. we obviously place the data within the storage system across different failure domains, so that you have redundancy for disk failures, server failure, rack failures, and so forth. That's really important in these type of environments where you scale out to a large number of servers and racks and so forth. Now, the Replicast protocol is specifically designed to be an auto-configured service in a dedicated storage network, either be it a physical network or a VLAN, but really it's a 10 gig network that's dedicated for storage networking. It allows us to very easily grow our cluster by connecting new nodes. They are auto-configured as soon as you install the NexentaEdge software. They allow you to connect to the cluster and join the cluster and participate in the storage system. So very easy to grow. It also allows us to reduce the actual overhead of our networking components and the communication between servers within a scale-out environment. And using the Replicast protocol, we can actually, in some cases, reduce the back-end network requirements and the actual bandwidth requirements by as much as 2/3 by using modern technologies based on IPv6 and multicasting. And to be really clear about that, IPv6 or multicasting is something that we only use between our storage servers on our dedicated VLAN. It's not something that a client would need to see or work with. So it's really abstracted from all of that, and it's internal to the product. So all of these different technologies give us a number of advantages, I should say, within the ecosystem and what the capabilities are. So for me, the key to that is really that we're able to provide and service multiple types of workloads, either be it object workloads or block workloads from the same system. So we can do best-in-class kind of small random I/O using block services. Within the same system, we can provide high throughput, large object performance, all while maintaining end-to-end data integrity and advanced functionality that you come to expect from enterprise-type storage systems, such as the ability to do an unlimited amount of snapshots, be it either at a LUN level or as a version of an object or as a collection of objects or collection of LUNs. We can, at a very, very granular level, control what we snapshot and how you present that out. And that's really a key part of the technology that drives the storage backend, that cloud copy on write technology that I talked about. On top of this, we're providing inline data reduction through deduplication and compression. So all this, everything that you store within NexentaEdge is automatically deduplicated. It's automatically compressed. And this really allows you to have a very, very efficient storage backend. And in environments for private clouds, for example, you can see a very, very high data reduction rate because virtual machines contain a lot of the same information, and as you instantiate new ones, we can reduce that down to almost a single copy. On top of this, we've spent a lot of time simplifying the operational model. We really wanted to make sure that this system over time is very easy to maintain and run. Not only so that you can grow it easily by adding additional capacity and performance, either be it new storage nodes or new gateway nodes or just but also so that we react to errors or failures, I should say, in the sense of if you have a disk failure, a network failure, or a server failure, we need to be able to maintain performance and allow the data writes and ingest to flow around the problem. And a key tenet to this is really the FlexHash algorithms and that negotiation that we do, allowing us to place data dynamically on the best suited devices. That really allow us to work around any type of failure within the system. It also allows us to self-balance and avoid hotspots for performance. And that's something that also becomes very important as you grow your environment, because if we go back to what Ashish mentioned, in a large environment, when you start growing your clusters to petabytes and petabytes, realistically, you're not going to have the same identical servers across your storage estate, because you buy one now, and in 3 years you have something different, or next year you want to buy a different server. All of those need to be able to work together, and the data storage system can't really create these involuntary hotspots. NexentaEdge is designed to avoid those hotspots and automatically balance across these different types of servers. So really, the way we've designed NexentaEdge really speaks to a lot of the demands of these new workloads that we saw. The ability to scale on demand, the ability to address multiple workloads within the same system, while maintaining an infrastructure that's not only cost efficient in the terms of the storage and server hardware that you can use, and that being driven by a software-defined storage model where you can design your solution based on your particular needs, your particular vendors, but also based on the operational costs that it takes to actually run the system over time. Because let's face it, we all know that we're not getting more money in our budgets to run our data centers, yet, at least not for operational costs in the sense, yet we are expected to run with larger and larger storage capacities over time. So we designed NexentaEdge to provide block storage and iSCSI, or through iSCSI, and object storage through Swift and S3 to hundreds of petabytes of storage. That's really the key elements of what we're capable of doing, and we do this while maintaining end-to-end data integrity, the ability to do enterprise-type storage operations throughout the storage infrastructure. And this really allows us to address those new workloads around private cloud backends, pulling storage back from things like public cloud deployments in Amazon, addressing the active archive use cases where you have multi-petabyte deployments on site, where you see that going up by the terabyte a day, so to speak. You just see a continuous growth, a continuous high throughput. Those applications are exactly what we designed NexentaEdge for. With that, we're going to open it up for questions, both for myself and for Ashish. And for all of those of you on Twitter, we actually have a running contest right now. So if you want to participate in that contest and for the Apple TV giveaway, please tweet the answers to a question that I'm going to give you in a couple of seconds using the hashtag NextPrize, and use our Nexenta handle at Nexenta. So what we want you to answer is really, mention at least 3 of the key differentiators with NexentaEdge. Some of the technologies that we use within NexentaEdge to deliver on these new workloads. We'll announce the winner of this Apple TV through Twitter 30 minutes after this webinar ends. So good luck. With that, I'll kick it off with some of the questions that we've gotten through our chat. And let's see here. You mentioned that NexentaEdge uses deduplication. At what block size do you do? And that's something that we can actually tune very well. We have the ability to set our block size or deduplication block size from large to small. So we can go all the way down to a 4K deduplication block size that would be deduplicated across your entire storage estate. So if you have petabytes and petabytes of storage, we could actually track and maintain that. And here I think we have a question probably for both me and Ashish. In the sense of, Ashish, why does it matter if an object storage solution is software only?
So that's a great question. The premise of that, to go back to the start when I talked about software-defined storage, one of the fundamental design points of software-defined storage is the decoupling of software and hardware, and the ability to run that software stack on a industry standard commodity off-the-shelf hardware system. So you could literally buy any type of server and run that stack with full capabilities on that server. So it really is about offering the choice and flexibility to procure your own hardware, own server hardware, and run the storage system on it. So if you have a relationship with a vendor and you would rather buy servers from that vendor, then the storage vendor should not be the one sort of preventing you from procuring that server. So it's really about choice and flexibility.
Yeah, I absolutely agree with that. So from my point of view, the only thing I would potentially add to that is that I think the ability to innovate in the software layer is quicker, and it's a quicker turnaround cycle to innovate in software than it is in actual physical hardware. So what we've seen over the last couple of years is that we can utilize the existing hardware and the emerging hardware solutions with intelligent software to really innovate quickly and kind of address these emerging workloads. And I think that's actually a big premise of these workloads as they are emerging as well. They're innovating very quickly, and they're doing that through software.
Yep.
So here's another question for me. What is NexentaEdge integration with OpenStack? And what we've done with NexentaEdge and the integration into OpenStack is really provide integration into various components of OpenStack. So we provide a Cinder driver for NexentaEdge so that you can use NexentaEdge for block storage, obviously. That's all your virtual machine storage, or potentially your data storage. We also provide OpenStack Swift APIs, an integration at an endpoint into Keystone so that you can use OpenStack Swift APIs with OpenStack, all the data hosted on NexentaEdge. Thus, we can also store glance image and take image repositories from and store that on NexentaEdge. We also have a visualization plugin into the Horizon dashboard so that you can get a point-in-time status view of how's your storage doing and so forth. Okay, so another question for you, Ashish. Regarding the important attributes of leaders, what about networking and how the provider address it with their solutions? What do you see as important here?
So could you repeat that question again?
Regarding important attributes of leaders, what about networking or storage networking and how the providers or I guess the companies and solutions are addressing it with their solutions? What do you see as important here?
So that's an excellent question, because one of the sort of, again, architectural principles of software-defined storage and object storage certainly is the fact that they are shared nothing architectures. So when you are talking about shared nothing architecture, by default, the servers use networking as an important attribute or a crucial attribute for internodal communication. So the servers or the controllers talk to each other over the network to exchange stateful data, and they also talk to the clients that access that network for the data ingest and access point. So from a networking perspective, there's a few things that, and this is not an all-encompassing list, but certainly a few things that you have to keep in mind. One is the ability to segregate the client-server traffic from the internodal traffic, so whether you build separate networks or not. Secondly is the chattiness of the servers on the network. So you really want to be able to make sure that the servers are not too chatty and that they are, conserving bandwidth. The third is the ability to, how manage the statefulness of that system across multiple locations and data centers. And the fourth is, how does the system as a whole handle, the break of a network. So if the network goes down between two data centers, how does it handle split brain condition or partition tolerance, as they would call it? How is availability impacted because of that? How is replication impacted because of that? So it's really about looking at networking as a core design principle for all of the storage solution and not just as a separate one.
Excellent, thank you. So here's another question. Can you elaborate on the differences between FlexHash and consistent hashing algorithms? So consistent hashing algorithms are what a lot of the traditional scale-out object storage solutions use. And it has a number of good things, but also a number of disadvantages associated with the technology. It really means that when you create a hash of an object, that hash points to potentially 3 servers within the infrastructure, or 3 devices, 3 disks. Because it's consistent, it's always going to point to those 3 devices. And if you have a device failure, we're going to need to rebalance that, or you're going to need to move that data, restore the resilience, before you really have the ability to do full ingest at full speed again. So that's one of the disadvantages that we wanted to avoid with FlexHash. So FlexHash uses a consistent hashing algorithm as a starting point. So it allows us to use the distribution of a consistent hash, so you get an even distribution as a base across your entire storage estate. But instead of picking 3 devices, and only 3 devices, we pick a group of devices, and that group is bigger than 3. It would be, depending on your storage cluster, but say it's between 10 and 20 drives or devices. We then, out of this list of devices, pick the 3. If we want to store 3 copies, we pick the 3 that has the lowest latency. And what this allows us to do is obviously not only performance optimize the write, but it also allows us to work around those issues where you have a device or a server failure, because in those cases, the latency of that device would be so high that it wouldn't be suitable as a storage target. So by leveraging latency, we can actually avoid some of the problems that you have with consistent hashing. It really comes down to technology, but it's really interesting how that works out. So with that, I think we're at the top of the hour. Thank you, everyone, for joining this joint webinar with Nexenta and IDC. We'll try to follow up on all the other questions that we have on Twitter. So please stay tuned there. And in about 30 minutes, we'll announce the winner of our Apple TV. So with that, thank you very much, Ashish.
Yep, thank you.
Pleasure to working with you.
Yeah, likewise. Thanks. Take care.